Python is a versatile, high-level programming language renowned for its readability and simplicity. But how did it come to be? The birth of Python. Conception: Python was conceived in the late 1980s by Guido van Rossum at Centrum Wiskunde and Informatica, CWI, in the Netherlands. Inspiration: inspired by the ABC programming language, Guido aimed to create a language that was equally powerful but easier to use. First release: Python's initial release was in February 1991 as version 0.9.0. Key milestones: Python 1.0, released in 1994, introduced functional programming tools like lambda, map, filter, and reduce. Python 2.0, launched in 2000, brought significant improvements like list comprehensions, garbage collection, and Unicode support. Python 3.0, released in 2008, marked a major revision aimed at addressing fundamental language flaws. While not fully backward compatible, it introduced improvements in syntax and efficiency. The rise of Python. Open source: Python's open source nature fostered a large and active community contributing to its growth. Readability emphasis: Python's focus on code readability made it popular for rapid development and teaching. Versatility: its applicability across various domains, from web development to data science, solidified its position. Python today. Python has become one of the most widely used programming languages. Its extensive standard library, combined with a vast ecosystem of third-party packages, makes it a powerful tool for developers. Guido van Rossum, creator of Python. Python. Python, a versatile programming language. Python is a high-level, general-purpose programming language renowned for its simplicity, readability, and versatility. Its emphasis on code readability promotes efficient development and maintainability. Key features: interpreted language, no need for compilation before execution. Dynamically typed, variables don't require explicit data type declaration. Object-oriented, supports object-oriented programming paradigms. Extensive standard library, offers modules for various tasks, reducing development time. Large and active community, provides ample resources, support, and third-party libraries. Why Python is popular. Readability: its clean syntax and emphasis on wit space make it easy to understand and write code. Versatility: suitable for web development, data science, machine learning, automation, and more. Rapid development: its interpreted nature and extensive libraries accelerate development processes. Strong community: a vast ecosystem of libraries and frameworks. Basic syntax. Python. Print, hello, world. Hashtag output, hello, world. Data types. Numbers, integers, floats, complex numbers. Strings, textual data. Lists, ordered collections of items. Tuples, immutable ordered collections. Dictionaries, unordered key-value pairs. Sets, unordered collections of unique elements. Control flow. Conditional statements, if, else, elif. Loops, for, while. Functions. Python. Def greet, name. Print, hello, name. Greet, Alice, hashtag output, hello, Alice. Example. Python. Def factorial, n. If n equals 0. Return 1. Else. Return n asterisk factorial, n, 1. Print, factorial, 5, hashtag output, 120. Applications: Web development, Django, Flask. Data science and machine learning, NumPy, Pandas, Scikit-learn. Automation, Selenium, Beautiful Soup. Scientific computing, NumPy, SciPy. Game development, Pygamy. What is Python? Python is a popular programming language. It was created by Guido van Rossum, and released in 1991. It is used for web development, server-side, software development, mathematics, system scripting. What can Python do? Python can be used on a server to create web applications. Python can be used alongside software to create workflows. Python can connect to database systems. It can also read and modify files. Python can be used to handle big data and perform complex mathematics. Python can be used for rapid prototyping, or for production-ready software development. Why Python? Python works on different platforms: Windows, Mac, Linux, Raspberry Pi, etc. Python has a simple syntax similar to the English language. Python has syntax that allows developers to write programs with fewer lines than some other programming languages. Python runs on an interpreter system, meaning that code can be executed as soon as it is written. This means that prototyping can be very quick. Python can be treated in a procedural way, an object-oriented way, or a functional way. Good to know. The most recent major version of Python is Python 3, which we shall be using in this tutorial. However, Python 2, although not being updated with anything other than security updates, is still quite popular. In this tutorial, Python will be written in a text editor. It is possible to write Python in an integrated development environment, such as Thonny, Picarm, NetBeans, or Eclipse, which are particularly useful when managing larger collections of Python files. Python syntax compared to other programming languages. Python was designed for readability, and has some similarities to the English language with influence from mathematics. Python uses new lines to complete a command, as opposed to other programming languages which often use semicolons or parentheses. Python relies on indentation, using witty space, to define scope, such as the scope of loops, functions and classes. Other programming languages often use curly brackets for this purpose. Python syntax, a comprehensive overview. Python's syntax is designed for readability and simplicity. Let's explore its key elements. Indentation. Python relies heavily on indentation to define code blocks. 4 spaces are commonly used. Consistent indentation is crucial for correct program execution. Python. If condition. Hashtag indented block for true condition. Else. Hashtag indented block for false condition. Comments. Single-line comments start with hashtag. Multi-line comments use triple quotes, or Python. Hashtag this is a single-line comment. This is a multi-line comment. Variables and data types. No explicit declaration needed. Dynamic typing, variable type is inferred at runtime. Python. X equals 10 hashtag integer. Y equals 3.14 hashtag float. Name equals Alice hashtag string. Operators. Arithmetic, plus, dash, asterisk, slash, percent, slash slash, floor division, exponentiation. Comparison, equals equals, 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 equals. Logical, and, or, not. Control flow. If, else, elif for conditional execution. For and while for loops. Break and continue for loop control. Python. For I in range, 5. Print, I. While x0. X dash equals 1. Functions. Defined using the def keyword. Python. Def greet, name. Print, hello, name. Classes. Python supports object-oriented programming. Python. Class person. Def underscore underscore init underscore underscore, self, name, age. Self.name equals name. Self.age equals age. Modules and packages. Organize code into modules and packages. Python. Import math. Import my module. Additional features. List comprehensions, create lists concisely. Generator expressions, create iterators efficiently. Exception handling, try, except, finally blocks. Remember, Python is case sensitive. With space matters. Use meaningful variable and function names. Python comments, explaining your code. Comments are essential for making your Python code understandable, both for yourself in the future and for others who might work on your code. Python provides two primary ways to add comments. Single-line comments. Purpose, used for short explanations or notes. Syntax, begins with a hash symbol, hashtag, and continues to the end of the line. Example. Python. Hashtag this is a single-line comment. X equals 5 hashtag this is a comment after a code line. Multi-line comments. Purpose, used for longer explanations or documentation. Syntax, there's no dedicated syntax for multi-line comments in Python. However, you can achieve a similar effect by using multiple single-line comments or triple quotes, or examples. Python. Hashtag this is a multi-line comment. Hashtag using multiple single-line comments. This is a multi-line comment. Using triple quotes. Important notes. Comments are ignored by the Python interpreter. While triple quotes can be used for multi-line comments, they're primarily used for docstrings, documentation strings, that provide information about functions, classes, and modules. Effective comments should explain the why of your code, not just the how. Example. Python. Def calculate underscore area, length, width. Calculates the area of a rectangle. Args. Length, the length of the rectangle. Width, the width of the rectangle. Returns. The area of the rectangle. Area equals length asterisk width. Return area. In this example, the docstring provides detailed information about the function's purpose, parameters, and return value. Python variables, containers for data. What is a variable? Think of a variable as a named container that stores a value. This value can be of different types, such as numbers, text, or even more complex data structures. Creating a variable. In Python, you don't need to declare a variable's type beforehand. You simply assign a value to it, and Python automatically determines its type. Python. X equals 10 hashtag integer. Name equals Alice hashtag string. Is underscore student equals true hashtag boolean. Variable naming rules. Must start with a letter or underscore. Can contain letters, numbers, or underscores. Case sensitive, age and age are different. Avoid using Python keywords as variable names. Common data types. Integer, whole numbers, example 42, -10. Float, decimal numbers, example 3.14, 2.5. String, textual data, example hello, world. Boolean, true or false values. Example. Python. Hashtag different data types. Age equals 30 hashtag integer. Height equals 1.75 hashtag float. City equals New York hashtag string. Is underscore employed equals true hashtag boolean. Dynamic typing. Python is dynamically typed, meaning you can change the data type of a variable after it's created. Python. X equals 10 hashtag X is an integer. X equals hello hashtag now X is a string. Best practices. Use meaningful variable names, example customer underscore name instead of C. Avoid single letter variable names unless they're commonly used, like I in loops. Use consistent naming conventions, example lowercase with underscores. Variable assignment and references. Assignment. When you assign a value to a variable, you're essentially creating a reference to that value. Multiple references. Multiple variables can refer to the same object. Mutable and immutable objects. Mutable, objects whose values can be changed in place, example lists, dictionaries. Immutable, objects whose values cannot be changed after creation, example numbers, strings, tuples. Python. X equals 1, 2, 3. Y equals X hashtag both X and Y refer to the same list. X0 equals 10 hashtag modifying X also affects Y. Print, Y, hashtag output, 10, 2, 3. A equals 5. B equals A hashtag both A and B refer to the same integer value. A equals 6 hashtag now refers to a different integer, B remains 5. Print, B, hashtag output, 5. Variable scope. Global variables, defined outside functions, accessible from anywhere. Local variables, defined within functions, accessible only within that function. Enclosing variables, defined in outer functions, accessible within nested functions. Built-in variables, predefined variables in Python, example len, print. Python. X equals 10 hashtag global variable. Def my underscore function. Y equals 20 hashtag local variable. Print, X, hashtag accessing global variable. Print, Y, hashtag accessing local variable. My underscore function. Del keyword. Deletes a variable and its reference. Use with caution as it can cause errors if the variable is still used later. Python. X equals 10. Del X. Hashtag print, X, hashtag this would raise a name error. Variable types, recap. Numeric, integers, floats, complex numbers. Text, strings. Boolean, true or false. Sequence, lists, tuples, ranges. Mapping, dictionaries. Set, sets, frozen sets. Additional considerations. Variable naming conventions, use descriptive names, follow PEP 8 style guide. Type hints, optional add type information for better readability and potential static type checking. Constant variables, use all uppercase for variables that should not change. Python data types. Python offers a variety of built-in data types to handle different kinds of data. Let's explore them. Numeric types. Int represents integer numbers, example -2, 0, 10. Float represents floating point numbers, example 3.14, -2.5. Complex represents complex numbers, example 2 plus 3j. Text type. str represents sequences of characters, example hello, world. Sequence types. List, ordered and mutable collection of items, example 1, 2, 3, apple. Tuple, ordered and immutable collection of items, example 1, 2, 3, apple. Range, represents a sequence of numbers, example range, 5. Mapping type. Dict, unordered collection of key-value pairs, example name, Alice, age, 30. Set types. Set, unordered collection of unique elements, example 1, 2, 3. Frozen set, immutable version of set, example frozen set, 1, 2, 3. Boolean type. Bool, represents true or false values. Binary types. Bytes, immutable sequence of bytes. Byte array, mutable sequence of bytes. Memory view, object providing a view of the memory of an array-like object. Special type. None type, represents the absence of a value, example none. Example. Python. X equals 10 hashtag int. Y equals 3.14 hashtag float. Name equals Python hashtag str. Fruits equals apple, banana, orange hashtag list. Person equals name, Alice, age, 30 hashtag dict. Numbers equals 1, 2, 3 hashtag set. Is underscore valid equals true hashtag bool. Determining data type. You can use the type function to find out the data type of a variable. Python. Print, type, x, hashtag output, class int. Important notes. Python is dynamically typed, meaning you don't need to declare the data type of a variable explicitly. Data types determine the operations that can be performed on a value. You can convert between some data types using built-in functions like int, float, str, etc. Sure, here is a more detailed explanation of Python data types. Data type. Description. Example. Operations. Int. Represents integer numbers. 10-5. Arithmetic operations, plus, dash, asterisk, slash, %. Float. Represents floating point numbers, decimal numbers. 3.14-2.5. Arithmetic operations, plus, dash, asterisk, slash. Complex. Represents complex numbers, numbers with a real and imaginary part. 2 plus 3j. Limited operations. str. Represents sequences of characters, text. Hello, world. String manipulation, indexing, slicing, concatenation. List. Ordered, mutable collection of items. 1, 2, 3, apple. Indexing, slicing, adding / removing items, iteration. Tuple. Ordered, immutable collection of items. 1, 2, 3, apple. Indexing, slicing, iteration, cannot modify elements. Range. Represents a sequence of numbers. Range, 5. Iterate through the sequence. Dict. Unordered collection of key-value pairs. Name, Alice, age, 30. Accessing values by keys, adding / removing key-value pairs. Set. Unordered collection of unique elements. 1, 2, 3, Apple. Membership testing, adding/removing elements, set operations, union, intersection. Frozen set. Immutable version of set. Frozen set, 1, 2, 3. Membership testing, iteration, cannot modify elements. Bool. Represents true or false values. True, false. Logical operations, and, or, not. None type. Represents the absence of a value. None. Used to indicate that a variable has no value. Export to sheets. Additional notes. Python is dynamically typed, meaning you don't need to declare the data type of a variable explicitly. Data types determine the operations that can be performed on a value. You can convert between some data types using built-in functions like int, float, str, etc.